So now let's put it all together and do a hypothesis test when we know the population standard deviation sigma. So this would be a z-test for the mean mu. All right, so what we're talking about is we're talking about trying to test the mean mu based on a test statistic on the sample. So that would be the sample mean. So in order to get the z value, we would do our standard transition to z from x bar when we know sigma. All right, so this was the same z-score calculation we were doing when we were doing sampling distributions. So what do we need for this? We need the sample to be random, and we need at least one of the following. This is the same as before. Either the population is normally distributed or approximately normally distributed, or the sample size is at least 30. So we need one of those two things. And remember that this term in the denominator, that's the standard error of the mean, sigma x bar. So that's the standard error associated, the standard deviation associated with the sampling distribution. All right, so let's take a look. How would this run out? So this is the whole, everything we would go through in doing this hypothesis test. All right, so if we're doing a z-test, we would have to have sigma known. We always need the sample to be random. And then we need one of those two qualifiers. We need either the population is normally distributed or the sample size is at least 30. All right, if we have that, then we set up our hypothesis test. All right, identify the null and alternative hypotheses, H naught and H sub A. Specify the level of significance, most likely given to us. So we want to figure out what alpha we're talking about here because that's going to affect our decision making. Then use the data from the sample to find the standardized test statistic z. So we'd be using x bar from the sample. Mu is something that will be based on the hypothesis we've set up. Right? That's the hypothesized mean. And then sigma we know because that's why we're doing the z-test here. And little n is our sample size. All right, so once we have z, then we need to find the area that corresponds to that z value, because that's going to help us decide how to get p, the p value. So for a left tail test, again, we'd be finding area in the left tail, right tail, area in the right tail. And for two-tailed, we'd find either one of those, most likely the left-tailed area, because that's easiest to find using the function. And then we're going to double it because we need the area from both tails in that case. All right, so that's how we're going to find p. The whole idea there was finding p based on areas. Then we take p and compare it to alpha. All right, so that's how we're going to make our decision. And remember, our decision is one of two things. We're either going to reject the null hypothesis or fail to reject the null hypothesis. If p is less than or equal to alpha, we reject the null hypothesis. If not, so if p is greater than alpha, we fail to reject the null hypothesis. Then we make then we interpret the decision. So here we were making the decision, now we're interpreting the decision. This is when we have to decide, are we in support or rejection mode? And then do we have enough evidence to support, or do we not have enough evidence to support? Or on the flip side, do we have enough evidence to reject the claim, or do we not have enough evidence to reject the claim? So this is all about whether we're supporting or rejecting the claim, not H naught anymore, the claim. So let's see it in a full example here. All right, so this is the text of the example. In auto racing, a pit stop is where a racing vehicle stops for new tires, fuel, repairs, and other mechanical adjustments. Efficiency of a pit crew, blah, 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 can affect the... Okay, a pit crew claims that the mean pit stop time is less than 13 seconds. A random sample of 32 pit stop times has a sample mean of 12.9. Assume the population standard deviation is 0.19. Is there enough evidence to support the claim at alpha equals 0.01? Use a p-value. Okay, so let's gather all the information. A pit crew claims its mean pit stop time is less than 13 seconds. Okay, so we know mu less than 13 is the claim. We'll figure out where to put that later. Random sample of 32 pit stop times. Sample size 32, n. Has a sample mean of 12.9. X bar is 12.9. Assume the population standard deviation is 0.19. Sigma equals 0.19. And then we're given our level of significance, alpha 0.01. Okay, so this is all the information that we're going to want to put into this. So let's see. Let's verify. Well, we were told sigma was known, and that's why we're doing a z-test if we can. And it was a random sample, so that's good. And while we weren't told the population was normally distributed, we do have n of 32, which is greater than 30, so we're okay. So we can do our z-test. All right, the hypotheses. Okay, H naught and H sub A. Remember, what did we say? We said mu less than 13. All right, mu less than 13 does not have an equals, so it goes in the alternative, and that is our claim. The rest of mu less than 13 is mu greater than or equal to 13, and that's our null hypothesis. And again, we're going to be working off of mu equals 13, and that will be the assumption behind the distribution we're using. All right, the significance, we said alpha is 0.01. The standardized test statistic, okay, so remember that's z equals x bar minus mu over sigma over the square root of n. That will be 12.9 minus 13 over 0.19 over the square root of 32. All that we figured out from the given information. That's approximately negative 2.98. Okay, so that was just doing this calculation here. We get negative 2.98 for z. All right, so what does that mean? All right, let's get a little sketch to see what we're looking for. All right, well, I need to know, is this left tail, right tail, or two tail? Go back. Remember that where you look is the alternative. So this, because my alternative says mu less than 13, that must be a left tail. Remember, we look at the alternative hypothesis to figure out what it is. So it's a left tail. So this is telling me I want to look at the z I calculated to be negative 2.98, and I have to find this area here. So I'll go bring up my Excel. So equals norm dot s dot dist negative 2.98 true, giving me 0.0014. 0.0014. That's my area there. But for this left tail, that p-value is this area. It's exactly that area. Okay, So now I need to take this p-value and compare it to the alpha that I was given. All right, well, 0.0014. Let's compare that to the alpha, which was 0.01. There's my p, there's my alpha. 0.0014 is less than 0.01. My p is less than alpha, so that means my decision is reject H0. Okay, now I have to go back. In order to interpret this, I have to decide, am I in a rejection mode or support mode? That depends on where my claim was. My claim was in the alternative. Claim being in the alternative means I'm in the support mode. Okay, so okay, my claim was in the alternative, and I decided to reject H0. So when I'm in the support mode and I reject H0, bringing me to my claim in the alternative, that means there is enough evidence to support the claim at a 1% significance level. All right, there is enough evidence to support the claim at this significance level. That's my final interpretation.